All right, Longhorns, this is the 4.1 review for Algebra 2 Pre-AP, and the first problem we're going to do is problem number 1, and in this section we are going to simplify each radical. All right, so first of all, I want to talk about what to do with this number right here. Now, what I showed you what to do in the calculator is to do a prime factorization of this number so that you know what all the prime factors are. And when we do that, we get 2 times 3 to the 5th. Now you can do that using a tree or a table, or you can use your calculator. The next thing I do is I separate out these numbers so that I can see if I have any numbers that are at least to the 4th power. Because anything that's to the 4th power, I can take out of the radical. So right here, I can't take out the 2, but I can take out 1, 3. Because 5 divided by 4 is 1, with 1, 3 remaining. So I can take out 1, 3, and I have 1, 3 remaining. Then I look at the a to the 4th. Well, I can just take that out completely. So 4 divided by 4 is 1, so I can take out 1a. So I take it out and I put it right here. And then b squared, I can't do anything with that because I don't have at least 4 of them. I only have 2 b's, so that has to stay under the radical. So I left it under the radical. And then c to the 6th power, well, I can take out 1c here because 6 divided by 4 is 1. So I take out 1c, and I have 2 c's remaining, and I leave those under the radical. So my final answer is going to be 3ac, and here I'm going to multiply this 2 times this 3, and that gives me 6. And then I have my b squared and my c squared. And that's it, and this is simplified. The only other thing I want to be sure that you understand is that when you're writing your problem out, you want to make sure that you keep your index number all the way through your problem. So I noticed on some of the homeworks you guys were dropping this index. You can't drop that index. It has to be 4th root because this radical is the 4th root. So you need to make sure that each one of these has a 4 in the index. All right, the next problem we're going to do is problem 3. And in these, we're going to simplify each expression and write as a single radical. All right, so basically what we're doing here is we're rationalizing the denominator. So I'm going to go ahead and work this problem out, and then I'll explain step by step what I did. All right, so quite a lot going on here. First of all, we need to determine what we need to do to get rid of this radical right here. We have a 4th root, so everything underneath this radical needs to be to the 4th power in order to get rid of it. Now this b is already to the 4th power, so we don't really need to do anything with that. We're gonna go ahead and take out the b. So I did that right here. So what we're going to need to multiply the numerator and the denominator by is whatever makes this 9 some base to the 4th power, and whatever makes this a to the 4th power. Well, I would need to multiply that a times another a. So I would have another a. So this would be my other a. Now 9 is 3 squared, but I need that to be 3 to the 4th power. So what I need is another squared here. So I'm going to need 3 squared here, so that when I multiply these two things together, I get 3 to the 4th power. All right, so now I know that I need to multiply my numerator and my denominator by the 4th root of 3 squared a. Now when I do that in the numerator, I get 3a squared, which is the original 3a squared I had here, times the 4th root of 9a. So I just went ahead and squared this 3 and made it a 9. Now in the denominator, I have 5. I went ahead and took the b out because it's already to the 4th power, so I took it out. And then what I have next is my bases raised to the 4th power, which is what I wanted. So the 4th root of 3 to the 4th, a to the 4th. Now I can eliminate this radical because everything is to the 4th power and I can take everything out. And when I do that, it eliminates the radical. So I come down to my next step. I have my 3a squared, 4th root of 9a, which is what I had up here. And then in the denominator, I'm going to have 5 times the 3 that I take out from this radical, times the a that I take out from this radical, times the b that I took out earlier. So what I can do here at this step is I can go ahead and simplify this fraction. I can reduce the 3's, and I can reduce 1a, because I have a squared over a. So I can reduce by one of those a's. So what I get from my final answer is a. This should not be squared. Let me fix that. Since I reduced this a, if you look here, I reduced this a, so there should only be one a up here. So a, 4th root of 9a over 5b is what's left in the denominator. And this is the simplest that we can get this expression. All right, the next example we're going to do is number 6. And in this example, we're trying to solve for x. So we have a rational exponent. So the first thing we need to do is isolate our expression that has the rational exponent as its exponent. And so that would be the negative 8 minus 2x in parentheses to the 4/3. We need to isolate that. So I'm going to show the steps for that, and then we'll continue solving. All right, so the first thing I did here was I subtracted 4 from both sides of this equation. And that gave me negative 80 equals negative 5 times negative 8 minus 2x to the 4/3. The next thing I want to do is eliminate this 5 from this expression because I really don't want it in the way, so I just go ahead and divide out the negative 5, and I get negative 80 divided by negative 5 is positive 16 equals. And now I have my expression isolated. Now I'm ready for the next step. I'm going to multiply this rational exponent by its reciprocal so that I can get rid of this. And when I do that, I'm also going to multiply this number by the same reciprocal. So let me show you what that looks like. All right, so here we have the 16 raised to the 3/4 power, because in order to eliminate this rational exponent, I need to multiply it by its reciprocal. So what does that do? This is what happens when I take a fraction and I multiply by its reciprocal. Both of these values cancel out. The 4's cancel out and the 3's cancel out, and I'm left with 1. And that's really what I want this number right here to be. I want this number right here to be 1. So by multiplying this 4/3 by 3/4, it becomes 1. All right, so when I simplify all this, I get 8, because 16 to the 3/4 is 8. The 4th root of 16 is 2, and 2 to the 3rd power is 8. Then I have negative 8 minus 2, and I'm just solving for x now. This is just a linear equation solving for x. So I'm going to add the 8 to both sides. I get 16. And then I'm going to divide both sides by 2, and I get x equals 8. And that's my final answer, x equals 8. All right, the next example I'm going to do is problem 8. And in this problem, we're trying to solve for k. So the first thing we need to do, once again, is isolate this expression that's inside the radical. We want to isolate that first. So I'm going to isolate that by moving the k. Then I'm going to work the rest of the problem out and walk through the explanation of what I did. All right, so what I've done here is I have taken this k and moved it over to this side because I want to isolate this radical. So I've done that first. I moved this k over. Then the next step is to get rid of the radical. So to get rid of the radical, I need to square both sides. So I squared both sides. Now when you get this right here, k minus 2, the quantity squared, that is not k squared plus 4. That is not what that is. You have a middle term in here that you have to consider. If I was to break this into its two binomials and multiply it together, I would get this, a squared minus 2ab plus b squared. So that's what we have to do with this k minus 2. You're going to have this middle term of minus 2ab. All right, so I get k squared, and then 2 times k is 2k. 2k, that's my ab. 2k times 2 is 4k. So that's how I got this minus 4k plus 4, because negative 2 times negative 2 is a positive 4. So just make sure you're following this formula right here for squaring this binomial. All right, so now we've got 5k plus 4 equals k squared minus 4k plus 4. Now I'm going to solve for k. So I'm going to move this 5k and this minus 4. I'm going to subtract it. I'm going to set this equal to 0. Now what I end up with is a quadratic on this side that's going to have to be factored. I factor the quadratic. I get k equals 0 as one of my solutions and k equals 9 as the other. Now the very next step, and this is a very important step that you have to do, is check your solutions to make sure that they're not extraneous, one or both or neither. So you need to check that for both numbers to see if they work or if they don't work. So let's try that. All right, so when I check both of these numbers, I put the 0 in first, and when I did that, I got 5 times 0 plus 4 is 4 right in here. Square root of 4 is 2. I get 2. Well, 2 is not equal to negative 2. So this particular answer is going to be extraneous. So my 0 is extraneous. We can't use that because negative 2 does not, 2 does not equal negative 2. All right, then I tried the 9. When I plugged the 9 in, I got negative 9 plus, this reduces to 7. Negative 9 plus 7 equals negative 2. So that does work. So my k equals 9 is good. So we're going to put a box around that and say that that is our solution. All right, the next example I'm going to do is problem 11. Now problem 11 has two radicals in it. So we're going to have to square that twice. But what I want to do first is I want to get one of the radicals by itself. I'm going to go ahead and keep this one, this radical to the left, and I'm going to move this radical to the other side by subtracting it. And then I'm going to finish working out the problem, and then I'll again explain step by step what I did. All right, so for number 11, the first thing that I did was I moved this root x to this side of the equation by subtracting it. So I ended up with root x plus 11 equals 11 minus root x. And then what I need to do to get rid of this radical is square both sides. So I squared it, and I squared this side too. Now again I have that a minus b, the quantity squared again. So remember, when you're doing this calculation right here, that you're actually squaring a binomial. So that's 11 minus root x times 11 minus root x. And the way that foils out is 121 minus 22 root x plus x. And then what I have on the left side is just my x plus 11. Now I'm going to set that equal to 0 by subtracting x and subtracting 11. So I subtract the x over here, and I subtract 11 from my 121. The next step is to go ahead and simplify that. So I have 0 equals 110 minus 22 root x. Now I have another root, so I'm going to have to square that again. So what I'm going to do is move this 10 back over to the other side of the equal sign so that I can isolate this so that I can square it. So I move the 110 back over to the left. I have a negative 110 equals negative 22 root x. Now I can square this term right here. I don't have to divide by 22. I could if I wanted to. I don't have to. So whether you divide right here or not is totally up to you. I went ahead and left it there, but you could have divided by a negative 22. That would have been fine. Either way, it doesn't matter. You're going to get the same answer in the end. So what I did was I went ahead and squared these just the way they are. And then I get these rather large numbers, but it's okay because when they divide out really nicely. So 120/100 divided by 484, that gives me x equals 25. And that's it. So then I check my answer to make sure that it's not extraneous. And so I plug it back in and I find out that yes, it works. The square root of 25 is 5. Square root of 36 is 6. 5 plus 6 is 11, and it works. And that's it. All right, so this problem is not on your review sheet, but it is from your homework, rationalizing the denominator. This is number 5 from that homework, and I wanted to do this problem because there's a couple problems or maybe 1 or 2 problems on the test that are like this, and I wanted to make sure that you got some practice on one of these before you took your test. All right, so the first thing I'm going to do is simplify this fraction as much as I can before I rationalize the denominator. All right, so in this first step, what I've done is I have simplified this fraction first before I start rationalizing the denominator. That way I'm not having to work with quite so many terms and quite such large numbers. So the first thing I look at is I look at my numbers that are under the radicals and see, is there a way I can reduce those numbers that are under the radical? Well, if they're both under the radical, and if the radicals have the same index, which both of these do, of course, these are both root 2 indexes, I can reduce this 12 over 20 just like I could reduce any other fraction. So I know that 4 goes into 12 and 4 goes into 20. So I went ahead and I reduced this 12 and this 20 by 4. So, and what I ended up in the numerator was a 3. So 12 divided by 4 is 3. 20 divided by 4 is 5. So that's what I got right here. I got a 5. Okay. Then I did the same thing with the x's. Well, x squared over x to the third, that just leaves me with 1x in the denominator. And then y squared over y to the fourth leaves me with 2 y's in the denominator. And nothing up here in the top. So all I have left in the numerator now is 2 root 3 over, and then what I have left in the denominator is square root 5 xy squared. Now I'm ready to rationalize the denominator. All right, so in this next step, what I did was I went ahead and since the square root of y squared is y, I went ahead and took the y out of the radical. And then the next thing I did was, well, what do I need to multiply times root 5x to make sure this 5 is squared and this x is squared? Well, I just need to multiply by another root 5x. So I multiply my numerator and my denominator by root 5x. Okay, so what I end up with when I multiply the numerator by 2 root 3 times root 5x, I get 2 root 15x. And then the denominator, I get 5xy. And that's my final answer. All right, for the next problem, we're going to do number 14. And here, what we are trying to do is simplify the expression. So this is not that difficult to do. So we will do this one step at a time, and it's a very short, simple problem. So hopefully these types of problems on the test won't take you very long to do. All right, so here we have 81 to the 3 halves. 81 to the 3 halves simplifies to 729. And then we have x to the 4th power to the 3 halves. So what ends up happening here is you end up multiplying these two exponents together because this is a power to a power. So in power to a power, we multiply. So when I multiply these two together, I get this 2 reduces this 4 to 2, and I get 2 times 3 is 6. So our final answer is 729 x to the 6th. All right, the next problem we're going to do is number 16. And this is kind of a throwback to last semester. So we actually have two functions. We have f of x equals 4 to the x, and we have g of x equals 6 root x. And we're supposed to find the value of g of f of negative 3. So if you remember from last semester, we take this negative 3 and we plug it into f, the function f first. And then whatever we get there, we plug that into g. So we're going to start in the middle. We're going to work our way out. So let's plug negative 3 into function f first. So 4 to the negative 3 power. What is 4 to the negative 3 power? Well, that's the same thing as 1 over 4 to the third. And 1 over 4 to the third is 1 over 64. So that's the first part. Then the next part is we're going to plug that in to our function g. So we're going to plug 1 over 64 into function g. So function g, so g, we could just say g of 1 over 64. We could say that if we wanted. And we're going to write square root of 1 over 64. Well, if you remember that you can rewrite this as the square root of 1 over the square root of 64. That's the same thing as 1 over 8. Okay? So this is 6 times 1 over 8. And when you multiply 6 times 1 over 8, you get 6 over 8. Which reduces to 3/4. And that's your final answer. The next one is 19, and it's pretty easy. We're just rewriting this radical in exponential form, and this is pretty simple. Now I'm gonna have a radical, and inside my radical I'm gonna have a 3a. Now this fraction right here tells me what my index is gonna be. That 5 is gonna be my index, so I'm gonna put that right here. That's my index. And this 2 on the top is my exponent. So this is the index, and this 2 is the exponent. So what I'm going to have to do now is I'm going to have to put parentheses around my radical and raise it to the 2nd power. And that's it. All right, for one-like problem number 21, basically what we're doing is we have the lengths and widths of a shape, and they're written in terms of radicals. So let me just read the question here. Mr. Throop went hang gliding in Rio de Janeiro while he was there competing in the Olympics as a cyclist last summer. The surface area of his right triangular shaped glider is root 32 a to the 6b squared. If the measure of one side of the glider, not the hypotenuse, is 4 root 6 ab, find the length of the other side, not the hypotenuse side. In order to do this problem, we have to remember what the formula is for the area of a triangle. So the formula for the area of the triangle is 1/2 AB, where A is one side of the triangle and B is the other. Well, they've already given us the entire area. So now what we have to do is we have to take that area and divide by one of the sides. All right, so all I've done here is simply set this up for you to simplify this. And I've used this formula 1/2 length times height, which is the area of a triangle. And I said that 1/2 of the length, which is one of the lengths is this, so 1/2 the length times the height is going to equal this total area, which is what they gave us here. So in order to find this other height, which is what we're looking for, we're going to have to divide both sides by this value right here. So what I did was I simplified this 1/2 times 4 to just 2. So I'm dividing this radical by 2 root 6 AB. And once I do this simplification, I will get the other side value for H. So what we really end up with is a rationalizing the denominator problem. So what I'm going to do is I'm going to go ahead and reduce everything that I can inside the radicals before I try to rationalize the denominator. Because I can get rid of this A, I can get rid of this B, and I can reduce this 6. So let's go ahead and take care of that, and then we'll rationalize the denominator. All right, so this fraction right here reduces to root 16 a to the 5th b over 2 root 3. That's because this 32 over 6 reduces to 16 over 3. This a to the 6th over a reduces to a to the 5th. And this b squared over b reduces to just b. Now I can go ahead and take the square root of anything inside here that's square. Well, 16 is a perfect square, so I could take the square root of 16. That's 4. The square root of a to the 5th is a squared with an a left over, because 5 divided by 2 is 2 with 1 left over. And then the b, of course, just stays in there because we can't take it out. Then the bottom in the denominator, we're going to have 2 root 3. Then what we're going to do is rationalize the denominator by multiplying the numerator and the denominator by root 3. So what we finally get is 4a squared root 3ab in the numerator. And in the denominator we get 2 times 3, which is 6. 2 times 3, which is 6. And then, since we have 4 over 6, we can still reduce that fraction again. So we reduce it again by 2, and we get 2a squared root 3ab over 3. And that's our final answer. That's the length of the other side. All right, in our last problem, we are going to multiply these two radicals together and simplify them. So the first thing we're going to do is we're going to go ahead and break out these numbers that are underneath the radicals into their prime factors so we can see if there's anything that we can factor out first. All right, so I got all the prime factors, and 32 factors to, the prime factors of 32 is 2 to the 5th, and the prime factors of 18 are 2 times 3 squared. So now what I can do is I can multiply what's inside the radicals together by just adding these exponents together. So 2 to the 5th times 2 to the 1st is 2 to the 6th. And then we have a 3 squared, and we have an a to the 7th times a squared, which is a to the 9th. And then we have a b to the 5th times b to the 4th, which is b to the 9th. So we can do that. And then we're going to go ahead and simplify that. All right, so what I've done is I've found my prime factors, and I went ahead and multiplied these two radicals together. So when you multiply these two radicals together, you just add these exponents. So 2 to the 5th times 2 is 2 to the 6th. A to the 7th times a squared is a to the 9th, and b to the 5th times b to the 4th is b to the 9th. And of course, I also have my 3 squared. Now I can reduce this. I have my 4 over here. This is this 4 here. 4 times this radical. I can take out one of the 2's because I have 2 to the 6th, and I'm looking for the 4th root. So 6 divided by 4 is 1, so I can take out 1, 2, and I have 2 2's left, so 2 squared stays inside. The 3 squared I can't take out, so I leave it in there. The a to the 9th, 9 divided by 4 is 2, so I can take out 2 of the a's, and I leave 1 inside. And the same thing with the b. B squared, leave a b inside. Now I simplify this. 4 times 2 is 8. I have my a squared and my b squared. I have my 4th root. 2 squared is 4 times 3 squared is 9. 4 times 9 is 36. And then I have my ab. And that's it. That's the final answer for this multiplication and simplifying. And that's it. Good luck on your test. Make sure you come to tutorials if you need help. I'll be in the morning and after school. Please, please, please practice.